And today I'm going to be talking to you about some of the trends and initiatives with respect to network function virtualization. As part of the presentation, what we'll do is we'll go through the overall industry trends, what we are seeing in the industry today. Then we'll take a look at various architecture trends with respect to the network functions themselves. And then finally, we'll look at trends with respect to various platforms that are being employed or being used for these network functions. All right, so let's get started with the industry trends. So when we look at the development process, how did the evolution happen? So first we had what we call a waterfall model, where it started with coming up with a requirements document. Your requirements got baselined. Then you moved on to your high-level design. Then you went to detail-level design. You got those baseline. Then you went into maybe testing, functional testing, integration testing. And then at the end of all this cycle, you come up with the software, which is GA. And then after that, that software goes into another round of testing, maybe at a service provider location, and then it goes into production. So from the very beginning to the very end, we're talking months, if not years, right? So the services were being deployed, the new services that were being deployed were taking a lot of time to get into production. So next came the agile mechanism, wherein we started squeezing some of that timeline, maybe into weeks or a month. The idea here was we broke everything down into multiple sprints. And at the end of a sprint, maybe it was a week or 2 weeks, at the end of the sprint, you go back to the requirements, adjust your requirements again, write the code, test it again, and then finish a sprint and then go back. So we went from months to weeks, but then, there was still room for improvement. And that's where the DevOps model came in. DevOps model basically means that your development teams and your operation teams are working much more closely using some of the best tools that are available out there to reduce your time to bring your service into production. That's the idea behind DevOps. Then we came into started looking at the application architecture model and what improvements can be made there. We start with monolithic model. This is where maybe your hardware and your software are coming up as a bundle, your black boxes. What happened was the application then got broken down into much more of a n-tier or a distributed model. Then finally, we had to break it down further into much more smaller functional pieces, and that's where the microservices came into being. And idea here is that you have smallest function broken down into a microservice, and all these microservices, which together form a big application, are talking to each other using some kind of a standard mechanism, like standard protocols, for example, REST APIs, HTTP, etc. From development and packaging perspective, we definitely started with the physical server, like we just discussed about the notion of black boxes. Then we said, let's standardize the server part, the hardware part, and we went to the x86 and then started putting hypervisor on top of that and virtualized the software part on top of it. Now, from that, we did gain a lot of consistencies with respect to the hardware, but there was a performance penalty that was being paid, right, with respect to your virtualization piece in there, your hypervisor layer. So the next notion came in with respect to containers. The evolution was in containers, wherein we are completely removing the hypervisor layer and saying your host operating system will provide you the basic functionalities that you need for your application to run. You don't have to bring it as part of your application. From application infrastructure point of view, we moved from data centers to hosted model. And right now we are in cloud, right? We are in cloud model, wherein you can, depending on what kind of a cloud you want, maybe you want to be on a public cloud, and you can just swipe your card, so as to say, or put in a credit card details and get the infrastructure that you really need to run your application. Of course, there's another side to it. You really need to think about private clouds also for certain use cases. Maybe you are looking at security. Maybe you want to be much more closer to your end user. Think about the edge use cases, right? Then in some cases, you need better latency and throughput, those kind of things. That's, again, you're going towards private clouds. So that's the evolution from the industry point of view. But what we say today is it's not only about the code or the technology today. It's not just about that, right? Although we discuss just the technology right now, but it's more about the code. It's more about collaboration right now, right? It's more about change in culture, change in processes. So think about how things would have happened a few years back. Let's say a service provider or somebody wanted to solve a technical problem, technical challenge. They will form maybe a working group. Maybe they'll go to a specification organization. They'll say, let's start building a specification. At that point, yes, the service provider is there. It will attract some of the vendors to get into that group. And then maybe those vendors are already doing business with the service provider. Maybe they're not. Maybe they want to do business, and maybe that's why they're there. So it kind of makes it a small group where they're trying to solve a very specific problem, maybe very specific to a vertical, maybe just the telecommunication industry. But that doesn't scale. Okay, so what happens is, let's say they come up with a specification. That specification, vendors look at that specification and start building a product based on that. Once they build the product, they go into production or start thinking about going to production. And they realize that maybe they missed some parts, right? Like they missed something for which they probably have to meet the deadlines in production. They make it in the product and try to put it in production. But then they are kind of off from the initial specification. So they have to go to the next release cycle, modify the specification, and so on and so forth. And you can see how this sounds much like a waterfall model that I just described. So we need to go towards much more, an open model, and that's where the open source is driving a lot of the technological innovation. So let's look at some of the projects. So if you imagine that x-axis here is representing time, and y-axis is basically giving you idea of various products and open source projects that are coming up. On the left, in the 90s, we had the Linux. Then we look at Kubernetes, which is right now the #1 orchestration platform. Doesn't matter where it came from. It has its IT roots, right, coming in from Google, how they used it. But now it's getting into network functional virtualization. Then we have Akreno, which is the edge stack, which is, again, making use of a lot of open source projects. Then we have blockchain for Hyperledger, TensorFlow, machine learning. So a lot of new projects coming up in open source communities. So to meet the requirements today, right, the NFV requirements, the operator requirements, what are some of the key projects? So the one I listed here are from the Linux Foundation. The very one on top is the integration testing. This is where we are looking at interoperability testing, coming up with reference architecture with respect to NFV. From management plane, we have ONAP. The seed code came in from Ecom, from AT&T, but this is now being combined with open source Mano and other management and orchestration platforms. Ansible, again, it had its roots on IT side. You were basically just deploying some packages on your servers. But now it's dealing with standards like netconf and Yang to configure your network devices. It's actually being used inside ONAP also. The Akreno stack, Akreno Edge stack very recently came out. And then one thing I do want to point out here is, like we're talking about the change in culture. Many of these projects are now being led by the service providers. So if you look at Akreno, ONAP, OpenFE, AT&T is kind of leading the charge there. When we come to the cloud portion, we have OpenStack, which is your virtual infrastructure manager. This is your virtualization layer. OpenDaylight as the SDN controller. And again, OpenDaylight is being used in other projects also, like ONAP is making use of that. DPDK and FDIO are your fast data path technologies. Ceph is your storage. And Kubernetes, which we'll go in more detail, is your container orchestration platform. And on the infrastructure side, we have telecom infra project and open compute projects. All right, so 5G is the biggest technological innovation that we are seeing right now. So why not use that as an example and see how things are evolving and its journey towards microservices? Now, there are a number of use cases that comes into mind when you talk about 5G, requirement for low latency, high throughput, understanding the data streams, prioritizing the data streams. But then think about all those devices. We're going to be talking about IoT later on. So last time I read the report, it was like 9 billion to 10 billion IoT devices that are going to be connecting in 5G networks. Well, think about how many services that are going to spawn in your network, right? So what this picture is trying to show is, on the x-axis, intelligent distribution to the edges. And on the y-axis, it's showing you the level of automation that it requires. And then 1, 2, and 3, and 4 are the various stages of evolution. So on stage 1 is the management phase. What happens here is the operator is basically just saying, I want to virtualize. That's it. I just want to get the software out of your hardware, and then put that software in a virtualized form factor, put a hypervisor layer, and then have a cloud management platform to manage that application. We already passed that stage 1. Stage 2 is wherein we try to harmonize the platforms. This is where the provider is going to think, well, I picked 3 different vendors or 5 different vendors. Do I really need them? Maybe I need just 2 for competition purposes. Maybe I just need 1, right? Maybe just an open source one. So that's where they start consolidating these and come up with their whole infrastructure. So 1 and 2 is really infrastructure modernization. And we are pretty much past those 2. We are somewhere between 2 and 3 right now. 3 is where we start to transform your current VNFs into cloud native fashion. Again, this stage is also going to be pretty much lift and shift, right? Just like we did earlier, you're going to take your virtual machine, convert it into a container, and start using it. You're not going to go into the full-fledged microservices model, which will come up later. So in stage 4, when you start thinking about how to optimize that, that's when you start thinking, well, how is my microservice going to scale up? How is it going to scale down? Should it have state in it? Should I be able to run it concurrently with other microservices? Right? Those are the things that you start answering when you get to 4, and look at the level of automation. Right? When you actually go into microservices, remember at 3 you're pretty much just moving your virtual machine into a container form factor. You're not getting all the benefits, but at 4 you're trying to reap all the benefits of your underlying infrastructure also to get that scalability in place. All right. Is there a button that got pressed somewhere? Okay. Now do what? F5?
Slideshow, you can go in there.
Yeah, it's all grayed out. Yeah, go ahead. Get started. So so we are at the stage 4, and you can see how the level of automation has increased when we go into the microservices model. So how to build this? Let's take a look. So from virtual machines and container perspective, well, what's the big difference here? What are we gaining? What are we losing? So from virtual machine perspective, what you're getting is excellent isolation. You have that your own operating system within a hypervisor. So you get your own kernel, you get your own packages and everything, right? But when it comes to container, you're basically utilizing the common kernel, which is on your host. So you get container level isolation, which really means all the security is being managed by things like SE Linux. C groups comes into play, how you use your resources. But when it comes to common functionality coming in from the kernel, like system calls, for example, happening there, they would be, shared between various microservices. So of course, that's a negative here a little bit because we are still working on that and requires more programmability. But what really means is that if there is a vulnerability inside your kernel, it can affect your containers, your other containers. But you get excellent burstable compute and memory and overall low resource usage. So quickly going through some of the cloud native apps functions. So this was published a few years back, and you can see this is coming off more from an IT side of things anyway. It doesn't talk about networking, so we'll talk about it a little bit later. But it's really saying is, some common sense things that you need to take care of when you build a microservice or a cloud native, in a cloud native fashion. Have a code base, so that you can control your source code. Take care of your dependencies. So all your dependencies of your application should be part of your application. Your configuration should also be part of your application because you want to make sure that you're having consistent experience, right? You don't have to mess with configuration every time in a different environment. You have backing services also being treated as separate services. Don't make it part of your microservice. Separate your build, release, and run environments. The most important one I want to highlight here is about the processes. So it's saying the processes should be stateless, right? So what happens is when you want to scale out, you just should be able to add more microservices, and when you want to scale down and dispose of certain microservices, or maybe they just crash. In that case, you should not be losing the state. That's the important takeaway from this. Same thing applies for example, here it's talking about logs, just type backing services. Don't write your own logging system in every microservice. Just think of it as a service. Imagine all these thousands of microservices coming up with their own logging mechanism. So that's what it's trying to convey. But what about networking? So everybody tried to solve the networking in their own fashion, but let's take Kubernetes because that's the number one orchestration engine right now. So Kubernetes said a couple of things, three basic things in here, which is, and this is basically coming in from the virtual machine world. It's really saying that anybody who's going to adapt or start deploying in Kubernetes is going to first do a lift and shift. They're going to just take the application and then put it there, move it in a container. So at least make sure that it has similar feel when it comes from virtual machine to the container world. So it's saying don't use natting. Don't make natting as a prerequisite. So whenever your containers have to talk to each other, don't use network address translation. Whenever your container has to talk to the host, don't use network address translation. And whatever IP address that you give to your container is the one that it should be visible, right? And that's the one it should be using. So, don't try to do any additional work just so that you can patch the communication. Some of the Docker networking work, which was initially done, required natting, and Kubernetes was kind of an improvement of that. But it didn't solve some of the problems that you need to solve for network functions, right? It only had single network interface. Well, you need a management interface. You need a data plane, control plane. That didn't got taken care of. It only supports IPv4, thinking that, well, it's going to be all internal within cluster communication. Well, in networking world, you need to have network and switches which are going to talk externally. Limited network performance, it really didn't care about that too much because it was all IT application. Network wasn't really, didn't really require high throughput requirements at that point. And multi-tenant model for IP addressing, which really means is that if you look at the virtualized world, you can have a tenant with its own subnets and IP addresses, and you can have exactly the same IP addresses within a separate tenant, right? You can have that namespace isolation, tenant isolation. That doesn't exist in the container world. Every cluster IP address is unique, and the only way you can stop any kind of a communication is by policies. So you have to set up policies for all your containers in order to achieve that kind of multi-tenancy. All right, so let's talk about how to architect that. So if you're familiar with 5G, you're aware of probably the CUPS architecture, which is control and user plane separation. Idea here is simple. If you look at the VEPC architecture, the new service-based architecture for 5G, it's separating out your control plane and data plane, right? For example, service gateway would have control and data plane functions in 4G. It's going to separate that. 5G is coming up with a separate user plane function. So we are already working towards, getting into a model which will fit into the current architecture. And current architecture is really saying that all your data plane heavy functions, which require all these extra networking technologies, right, fast data path technologies, keep them as virtual machines still. That's what it's trying to show. And all the control plane functions, which are not data plane heavy, they have probably higher sessions, but not really user traffic, not that much of user traffic. Those things you can move as containers. So in the short term, you will have a hybrid architecture, which will basically say you will run virtual machines and containers together. So let's talk about some of the platform trends. Now, there are two major platforms that you need to think about. One is virtual machines that you already have running. You have your virtual infrastructure manager. And one thing you can do is run containers on top of that, right? This is the brownfield deployment. You already have virtual machine running, which works perfectly fine, right? You just have two different platforms. This is an example of Kubernetes and OpenStack. You just have two different platforms. The thing you really have to worry about here or think about is, well, you have two networking pieces also, right? These were two separate projects. Most likely they were for everybody, right? I mean, they have probably OpenStack deployment, VMware deployment, whatever it may be. But they have their own networking piece, and then your container will have its own networking piece. So you need to think about how to make that connection between the two. And that's where you have some kind of enhanced bridge architecture wherein you say, you don't want your container to use its networking. Make your container, architect your container platform such a way it uses the platform that exists already in your virtual machines for your virtual machines. And it gives you compliance with, think about the benefit it gets you. It gives you compliance with all the existing plugins or SDN controllers that you've already verified with your virtual infrastructure manager. The next one is going to be, let's say, a greenfield deployment, right? You want to start with the containers. Well, before you go there, you have to satisfy these requirements, right? You need certain CNI plugins so that they can give you features like SRIOV, DPDK, or fast data path technologies, right? You will need that at some point in future, not for the hybrid, but for the future. You need device plugins. So, for example, if you want a smart scheduling using the GPU, smart NICs, which exists in your hardware, you want to make use of that. Well, that's where you need device plugins to be created by the vendors, right? This is a plugin system, so that's what is needed. You need some kind of a network service mesh. Idea here is you want those cloud-native application microservices talk to each other, right? You need level of observability in that. You need a level of availability in that so that if certain route is not available based on your high availability policies, you should be able to go to an alternate route. And that's where network service mesh comes in. There's already a service mesh, which is called STO project, which is more on the application layer, but this is more on the layer 2 and layer 3. That's where your network functions reside. And then there is another interesting project coming up called Legato, which is giving you a container platform where you can develop your own cloud-native network functions. As you know, this platform will provide you some of the basic functionalities like networking using FDIO and VPP, the vector packet processing, and service function chaining from the platform itself. All right, from security and multi-tenancy, of course, there's another thing coming up. Now you have to worry about, like I said, you have a shared kernel, right? You have to worry about that. And the way you can solve it is there's a project called Kata Containers, which is coming up with a hypervisor layer, which is very, very thin. And it is also coming up with a kernel, which resides in there. So you're kind of creating a hypervisor layer across each container. Every container has its own hypervisor layer. So you get the security and multi-tenancy of the virtual machine. Remember that first graphic or second or third graphic that I talked about, and how virtual machine and containers kind of differentiate on that. So it's trying to fill up that hole in there with this architecture. And then finally, we talk about KubeVirt. So I said it's going to be hybrid architecture, right? You might want to run your existing virtual machines using Kubernetes platform. And that's something you can do with KubeVirt. It is up and coming, another open source project where you can run both along with it, and you can have a hybrid environment. And at some point, you can transform all that into container workloads. Finally, this is a sample reference architecture. You would probably have one for your own, within your own company. But this is the one Red Hat uses. But this is basically based on the HC and FV architecture. So you start putting in containers in there in the virtual infrastructure manager layer. You start putting Ansible and things like that you really want to work with within your own in your industry. All right. With that, any questions? Yes. Fedora? Okay. Oh, good question. So, Atomic was the container operating system. It was very lightweight. It was very opinionated version of Fedora. So Fedora is the full-blown Linux operating system. Atomic is just a subset of that, which makes sure it works well with containers, very lightweight, and you can't change and modify things for security reasons. That's where it fits. So when you build your container microservices, use Atomic. But now Atomic is being phased out for CoreOS. CoreOS is the new one. So Atomic is going to go away, and CoreOS is going to be the container Linux. That's what it's called now, container Linux. Atomic is still available, but it's being phased out with container Linux. Yeah.
How does the concept of network slicing fit into the creation of these services in 5G?
Right, so that's a 5G question, but that's a good question. So the idea here is when you have all these different, so we talked about CUPS architecture, right? So every time you want to slice a network, you can have the instances of those microservices that's going to be, maybe requirement of a higher bandwidth or throughput or latency, however you want to slice the network, right? So you create multiple of those, your user plane or control plane functions within 5G architecture. That's how it is. With respect to containers, it's just saying, well, you need more of those app microservices. I talked about concurrency, for example, not having states, so you just keep adding those. That's how you would do it. It's really a scalability thing. Okay. All right. Thank you.
Sachin, thank you very much.